Hey everyone, Michael Unger here from the MacMillan Space Centre, once again joined with our astronomer Rachel Wang, and we've got a whole host of really exciting topics to get into. Of course, this week is the moon, but Rachel, there has been a visitor that has visited us from the outer reaches of the solar system that has captured lots of people's imaginations. I think we should probably start off talking about Comet NEOWISE. Have you gone out and watched it?
I have, yeah. I went last weekend and saw it with my very own eyes.
So yeah, and I actually went out on Monday and Tuesday as well, and I was really amazed. And I'll just sort of like share my experience, and I would love to hear your experience as well because I made a couple of mistakes, and I think like that's something perhaps a lot of people out there, may experience as well. Because I went down to Kitts Beach to go and watch it. I was there, just after sunset. So sunset was like maybe like 9:15 p.m. or so. So I was there like 9:30 ish. But of course, it doesn't get dark in the west, which is where the comet is, for another hour. So I was out there for a while waiting for it to get dark, even though if I looked up and like turned around to the back towards the east, you could start to see stars and they were starting to appear, but over towards the west where the comet was, still wasn't dark yet. So really until like 10:30-ish, I really start to see it. What was your experience like?
So I actually went early in the morning. So I went
Right.
between 3 and 4 a.m., woke up in the middle of the night and saw it with my own eyes. So I thought it was kind of cool because I actually used my peripheral vision to see it because it was quite faint. So
Yeah.
I didn't look directly at the comet, but I looked a little bit to the right of it and used my sensitive rod cells in my eyes to be able to pick it up. And I actually was able to use the long exposure setting on my phone camera to
Okay.
capture a picture of the comet. So even with just your phone, I was able to get a picture of it.
Yeah, no, I was really amazed. I was with a couple of friends that were amateur astrophotographers, and looking at it again with your own eyes, using that averted vision, but then looking at their screen as they were taking the picture and just seeing, that tail really come to life was really fascinating. So the comet is still up there, and for people, not only here in Vancouver and British Columbia, but all across Canada, over into Europe, we can see the comet at least, hopefully, maybe for another week. So, Rachel, maybe you want to share with us maybe where people should be looking.
For sure. So to do that, I'll actually share my screen and show you a very useful website that I love to use, and that's called Time and Date. And I love it because it shows us the nighttime sky, what you can see on any given night or even during the daytime, and you can put in your location. So I've put in Vancouver, and I've clicked on the best time to view Comet NEOWISE over here in the corner. So for tonight, if you're going to go out, that time happens to be 10:47 p.m. And to look for it, you want to look for the constellation Lynx. That's where the comet is right now. You can find it because it looks like a giant zigzag across the nighttime sky. And as we go on through the days in the month, it'll start to go towards the Big Dipper, so Ursa Major. But I find it really useful to use the two stars in the bottom of the cup of the Big Dipper to help me guide myself to find where the comet is. It's almost like if you drew a line down and then went a little bit to the left, there the comet would be.
Awesome. Yeah, and of course, anyone out there on YouTube watching right now, if you'd like to get in, ask us some questions about the comet before we get into the moon, we can take this time to answer them. Yeah, I find this really fascinating. We talked a little bit about comets and like the two tails, and I think another really interesting perspective is when you're looking at the comet and you see that beautiful tail. I think a lot of people sort of like have this perhaps cartoon image in their head of like a comet streaking across the sky, but that's really not what's happening because that tail is actually leading the comet away from the sun, right?
Exactly, yeah. So that tail is a dust tail, and it points away because it's actually radiation pressure from the sun. So photons coming from the sun actually imparting momentum and pushing the dust behind the comet.
And I noticed that you had mentioned in a couple of your interviews, because you've been certainly getting lots of questions from the public about the comet. You had talked about the two different tails.
Mhm.
Maybe describe to us what those two different tails are.
Sure. So the tail that you'd be seeing would be the dust tail. So it's kind of that feathery white tail that you see trailing behind. But there's also a smaller blue tail that actually points in a different direction. And that's the ion tail. And the reason why they point in different directions is because the sun affects them in different ways. So like I said, the dust tail is affected by photons coming from the sun. We call that radiation pressure. But the ion tail is affected by solar wind. And so if you've seen a few pictures of the comet, those with the astrophotography skills that I don't have and have that long long exposure camera, you can actually see the blue tail a little bit to the left of the feathery dust tail.
Yeah. And from my experience as well, I don't own a pair of binoculars, but from what I've heard, if you have that long lens in your camera or a pair of binoculars, those are probably the best. I didn't try to look at it through a telescope, but I heard some people that had, and you do get a close-up look maybe at the nucleus, but I think to really get the beautiful effect of the comet, you want to get that tail too. So maybe not so close up is the view that you want. But we do have some questions coming through. Of course, a friend of our weekly chats, Pride, who came to our event yesterday in Telescope. Hey, Pride. Do our eyes focus more detail the longer we look at an object in the distance? Pride says that she seems to be experiencing this, for example, the phases of Venus. So maybe talk about how our eyes adjust.
Interesting. So we know that we have to dark adapt first of all. So you do want to let yourself, when you do go to a dark sky location, to let your eyes adjust at least 20 to 30 minutes to really be able to pick up small details like the comet's tail. And your eyes have both rod and cone cells. Cone cells are for color, rod cells are for dim light. And so you have more rod cells towards your periphery, which is why I used averted vision to look for the comet tail, but your eyes do get tired. So you want to make sure that you do go to a dark sky location, have that dark adaptation, and use that averted vision.
Right. And another really good tip as well, what sort of happens when I go down to the beach is that there's sort of like people gathering around. They sort of see, oh, you're looking for the comet as well. Another really common mistake is that everyone uses their phones for their sky apps to try to figure out where it is that you're looking. But your phone gives off a bunch of white light, which is exactly not the light that we want, right? So you're talking about, Rachel, is that red light is not going to ruin that dark adaptation.
Exactly. And I actually use an app to help me position myself. And it's called Skyview, and that actually has everything in red, and it has altered reality. So what I can do is I can point my phone at the night sky, locate any constellation I want, and help me guide myself to that comet.
Awesome. Another quick question. We're going to just focus here on Comet NEOWISE for a second, then we're going to get into the moon. But we got to talk about the comet. This is what everyone's talking about. So Harry,
once in a lifetime.
I know. Was it 6,800 years or
it
something?
It is. Yep.
So this orbit, that's actually what Harry is talking about. It's the orbit. So maybe talk about sort of like the direction and a little bit about where it's going and who in our solar system.
Sure. So it's traveling on what we call a near parabolic orbit. So you can imagine, instead of having a circular orbit, if you cut open that circle and kind of stretched it almost to a straight line, that's what our comet is doing. And that kind of goes to show why we have such a long period before it comes back, because it's traveling on this really extreme path. And so, like you said, Michael, that period is 6,800 years. So it's definitely a once in a lifetime thing for us.
And I've seen a few pictures of this as well, in showing the trajectory of the orbit, is that where most of the planets and the asteroids in our solar system are sort of on that ecliptic plane. But this comet is not really in that plane. It's kind of going above the plane. Is that right?
Yeah. And part of the reason for that is because long period comets, the source of that is from the Oort cloud. And the Oort cloud is this hypothetical cloud that surrounds our solar system. And the reason I say hypothetical is because the Oort cloud has a lot of kind of ice, gas, and dust, and it's really diffuse. So the spaces in between all the stuff in that Oort cloud is very big. So light that ends up passing to the Oort cloud actually goes right through, and we need reflected light to be able to see things in space. So that's why it's still this kind of hypothetical region of space, but that's where we think long period comets come from.
Right. So if I bring up my orrery here, we kind of can kind of envision sort of like all the planets are sort of like on this ecliptic plane, all going around the sun. But what you're talking about is this Oort cloud, which is just sort of like surrounds, and it's in every direction. So this comet, whoop, my microphone just fell down there. So this comet is kind of coming from this direction, but comets could come in from all directions as well. Is that right?
Exactly. Yes.
All right. Well, if you have any more questions about Comet NEOWISE, you can put them into the chat. But like we said at the top, this week's theme is the moon. And I also had mentioned that Rachel and I were out at the observatory yesterday. We have been doing some in-person events, outdoors, socially distant, very safe. And we got a really cool experience to look at the moon with the telescope in the daytime. The moon is up there, not for long because it is in a waxing crescent phase, almost going to the new phase. But that leads us into what we're going to talk about with all of the future endeavors that we're going to do with the moon. So Rachel is going to do a quick little presentation on the moon, and then we're come back with some questions.
For sure. So here we are. I'm just going to share my screen. You should be able to see the moon. And let's talk a little bit about Earth's closest neighbor. I'm going to start off with some fast facts here. So first of all, the Earth and moon are tidally locked and almost like a gravitational dance. Their rotations are so in sync that we only see one side of the moon all the time. Humans actually didn't see the far side of the moon until a Soviet spacecraft flew past it in 1959. Now, the first definitive discovery of water was made in 2008 when the Chandrayaan-1 detected hydroxyl molecules, which is basically oxygen bonded to hydrogen. And it was spread out on the surface, but concentrated here at the poles. Since then, further exploration has shown us that not only does the lunar surface have global hydration, there are actually high concentrations of ice water in the permanently shadowed regions of the lunar poles. And finally, the moon's entire surface is cratered and pitted from impacts. It has too little of an atmosphere to impede impacts from asteroids, meteoroids, and comets. Now, over billions of years, these impacts have ground up the surface of the moon into fragments, covering the moon's surface with this powdery dust and rocky debris, which we call regolith. So let's talk a little bit about how it formed. Now, the leading theory of the moon's origin is that a Mars-sized body called Theia collided with the Earth around 4.5 billion years ago. And the resulting debris from the Earth and also from Theia accumulated to form the moon. Now, the newly formed moon was molten and hot, but with a few 100 million years, most of the magma oceans on its surface crystallized, with less dense rocks floating upwards and eventually forming the lunar crust. And we actually see remnants of these magma oceans today in the dark splotches on the surface called lunar maria. Now, just as the moon was becoming a stable environment, however, it went through a period called late heavy bombardment. This period has been a huge part of our origin story since samples were brought back from the moon during the Apollo era. However, since 2018, this idea has been called into question. There are many attempts to explain the spike in impactors in the inner solar system, one of which is called the NEOWISE model, which is popular among planetary scientists. It postulates that these giant planets migrated, and in doing so, actually scattered objects in the asteroid and Kuiper belts into the path of terrestrial planets. But in order to really settle this debate, researchers actually need new samples from the moon. And that brings me to the Lunar Gateway. Now, like the ISS, the Gateway will be assembled in stages using both NASA and commercial launch vehicles. The first two elements of the Gateway, the power source and habitation module, will be launched together in 2023, with other modules being added afterwards. By 2026, the Gateway is expected to begin science and technology demonstrations. Now, a common question is, why go back to the moon? We've been there before, why go back again? Well, the area of space around the moon can help us prepare for human missions to more distant destinations like Mars or beyond. So building a space station around the moon allows for a deeper understanding of possible health effects of astronauts living and working outside of Earth's protective bubble. Also, continual access to the lunar surface, a unique setting for testing technology, and also a unique perspective for observations of stars, our sun, and planets. And as we'll see later, there's still many things to be discovered about our closest neighbor. Now, for the Gateway, scientists decided to follow something called a halo orbit. It's a highly eccentric, non-circular path, and on this path, one revolution of the Gateway around the moon would take approximately a week. And the reason they chose this, and they chose this period, is to limit the number of eclipses when the Gateway would be shrouded by the Earth or moon's shadow. And this is important because the Gateway is solar powered. So what about moons on other worlds? Well, back in October last year, scientists actually found 20 new moons orbiting Saturn, bringing its total to 82 moons. That surpasses Jupiter, which only has 79. Now, 53 of these moons are confirmed and named, and another 29 of Saturn's moons are awaiting confirmation of discovery and official naming. Now, Saturn's moons range in size from larger than the planet Mercury, like its giant moon Titan, to as small as a sports arena. Now, these new moons were discovered using the Subaru telescope atop Mauna Kea in Hawaii. And Jupiter also has 63 confirmed moons, and the rest of them are awaiting confirmation. Jupiter's 4 largest moons, which you can see over here, are called the Galilean satellites, and they are Io, Europa, Ganymede, and Callisto. And to remember those, I eat green carrots with the first letter of each of those words, telling me what the first letter is of these Galilean satellites. Now, what's exciting is that we actually do have semi-recent moon news, so we're still learning stuff about our closest neighbor. So I'll share with you what that was. The Miniature Radio Frequency, or Mini-RF, instrument aboard NASA's Lunar Reconnaissance Orbiter recently found new evidence of the moon's subsurface and that it might be richer in metals than once thought. The mission actually started out as a hunt for ice lurking in the polar lunar craters, but evolved into data that could help draw a clear connection between the Earth and the moon's history. So using this instrument, scientists made measurements on an electrical property within the lunar soil on crater floors. And this electrical property is a really fancy number called the dielectric constant, but it really just tells physicists how well a material can transmit electric fields compared to the vacuum of space. But really what's important about this number is that it's directly related to the concentration of metal minerals in the lunar soil. So when making measurements, the team found that this electrical property remained constant with larger craters at the lunar South Pole, which is not what they were expecting at all. So they came up with a hypothesis. Their hypothesis was that a few hundred meters under the moon's surface, there's a wealth of metals underneath. So once they compared radar images from Mini-RF with metal oxide maps from a few other missions, the team found exactly what they had suspected. The larger craters that penetrate deeper into the lunar surface with their increased dielectric number were also richer in metals. Now, one possible explanation for this is that a metal-heavy asteroid impacted the moon, forming this crater and lodging itself in the moon. Now, the South Pole Basin formed around 4 billion years ago, when the solar system was much more chaotic and collisions between rocky and metallic bodies were happening much more frequently. But all in all, this is a very exciting development because it shows that even after many years of operation on the moon, we are still making discoveries about the history and composition of our nearest neighbor. Alrighty, and Michael, back to you.
Awesome, thanks, Rachel. So we'll get into, of course, all of your questions. If you want to talk about Comet NEOWISE, you want to talk about the moon, so much to talk about. But let's first go back to Comet NEOWISE. And Pride had a really good question about, so we talked about the orbit of the comet and it's leaving sort of like the ecliptic plane. She wants to know why it comes back and why it just wouldn't keep on going into maybe deep space.
So that's because of gravity, and that's because of the sun's gravity. So our comet is actually orbiting around our sun, even though it is on this parabolic trajectory, that it might seem like it isn't affected by the sun that much, but actually it's enough to kind of pull and tug on the comet just enough to keep it going around the sun. And what's kind of interesting is that the period of this comet used to be 4,500 years, but when the comet passed by its closest approach to the sun, that was on July 3rd, it actually boosted its period. So they went from 4,500 years to 6,800 years.
Wow. So this comet is relatively new to us and our understanding of it. So with every day, we're learning so much. So, and Harry wants to know when it was initially discovered and why we call it NEOWISE.
So it was discovered earlier this year, March 27th. And it's called NEOWISE because that was the instrument or the spacecraft that actually detected it. And what's kind of interesting is NEOWISE is a near-Earth object wide field infrared survey explorer. Right. That's NEOWISE, and that's the asteroid hunting portion of WISE by the same name. And so they named it NEOWISE because that's the one that discovered it, and it uses infrared and infrared signatures to figure out exactly like how big this comet is. And actually they found by combining visible light data and infrared data that the comet is around 5 kilometers across. So it's quite big.
Cool. Okay, it looks like we've got a lot of young people watching today, so we've got a couple really fun questions. This one is from Millen, talking about the first animal to go to the moon. Have there been any animals that have gone to the moon?
That's a good question. I know there's definitely been animals in space. I know that Laika was the first dog in space. I'm planning to get a tattoo of Laika just to merge my love of dogs in space.
Yeah.
And I know they sent a bunch of other different animals as well. And I think fruit flies is among that list. Maybe even I think I want to say some sort of amphibian as well. But I'm not too sure if any animals have set foot on the moon besides humans.
I don't think that we have. Although the Israeli spacecraft, the Parachute lander that crashed into the moon, it was meant to land on the moon. But I believe that there were some extremophiles that they had attached to that lander, and they were going to do some experiments. So technically, there may be some extremophiles, which are tiny microscopic creatures on the moon right now. Of course, barring that, you could just look up and maybe see the rabbit in the moon or some other shapes. Do you see any rabbits or other animals when you look up at the moon?
Uh, so I've tried to look for the rabbit in the moon, and for some reason, my brain just doesn't see a rabbit,
Yeah.
besides the dark splotches of the Maria. I don't know, but maybe I'll give it another go when we have another full moon.
Anyone out there? What animals do you see when you look up at the moon? And if you don't see animals, go outside next time and show us what you see. Another question from David, who's 8 years old. So the moon, when we saw it yesterday, was just a tiny little crescent. He wants to know why it disappears and then reappears.
So it goes through phases, and our Earth casts a shadow on the moon. So that's why you see the moon kind of wax and wane. And by wax and wane, I mean that kind of the light kind of goes across the moon and giving us these crescents, giving us these half moons, quarter moons, and full moons and new moons.
Okay, yeah. And so right now it's almost going into that new moon, so it's basically almost backlit from the sun, so almost disappearing. So we're not going to see the moon probably for maybe another week or so, maybe.
Exactly, yeah. And the new moon is actually one of the phases that we don't see during the daytime, just because of that reason that you said.
Right. Pride says that she likes cheese too much to see any animals, so she's got cheese on the brain. Um, um, So Harry, you talked about some of the theories of sort of like how the moon was formed, and of course that's a relatively new. I remember when I was first learning about the moon, I don't think that theory was fully formed. So do you know what any of the other sort of like leading theories, or maybe not leading theories, because that sounds like that is the leading one, but
Mhm.
any other potential theories about how the moon was formed?
Sure. Another idea is that perhaps Earth actually captured the moon. So Earth's gravity, maybe during formation, there's a lot of things going on. It's very hectic. It could have captured a large rock, or maybe something else smashed into that rock, forming a larger rock that was captured by the moon. So really, it is a recent development, but that seems to be the most likely explanation for how our moon formed.
Yeah, certainly. If you think about sort of like the models, and certainly that's I think where the scientific understanding of this comes from, is that they can actually model this out and sort of rewind time, kind of like how we do in the planetarium. We can show all of the orbits and go way back in time and sort of maybe try to piece together kind of like what happened. And it certainly kind of seems to me, just on a very basic level, that the moon being a captured asteroid seems kind of unlikely, just given how close we are to the sun. Certainly for the gas giants like Jupiter and Saturn, I think that is certainly more likely. And there's a lot of those moons that you just talked about probably could be captured asteroids, right?
Yeah, and it's interesting that you bring up modeling and these giant planets, because I talked about the Nice model, which is named after a place in France. And that idea was that these giant planets migrated, particularly Jupiter and Saturn. And so the idea is that they weren't actually where they are currently, but they were a little bit off. And then they migrated. And because they migrated and they moved, the gravity is so strong that they were flinging things left and right. And they ended up settling in a resonance. And by resonance, I mean, if you imagine pushing a child on the swing, it has a natural frequency where you push, they go higher and higher and higher. The same kind of thing happens with Jupiter and Saturn. And so they have a 2-to-1 resonance, which means for every time Jupiter goes around twice, Saturn goes around once. And so now they're in this kind of stable configuration, whereas before we think that they migrated from a little bit off to where they are now.
Right. So we've only got about 5 more minutes with Rachel, of course. Rachel, as we were talking, it was totally cloudy, and now it's almost starting to clear up. So I quickly looked at a website. If you're ever wondering, is it going to be clear enough to maybe see stars, maybe see the planets, which of course Jupiter and Saturn are out tonight. We can see them tonight, really high and bright in the south. A really good website that I go to is called Clear Dark Sky, and it's really accurate actually. And I just looked at it, and for about 11 o'clock, which I think would be like a good time to maybe start looking at the comet, it's saying only maybe like 10% cloudy, which was a lot better than what I would have thought, given like there were so many clouds.
Pretty good for Vancouver.
Yeah. So if you haven't seen the comet yet, super recommend going out there and seeing what you can find. Another random question for you, Rachel. If life beyond the Earth is found in the Earth, how would you react?
If life beyond the, can you?
I think the question is, if we were to find evidence that there is life here on this planet that didn't originate here.
Oh, interesting. In science, I always say that you shouldn't rule anything out until you have very substantial evidence that you should rule things out. And, like learning new things about our moon that we've had as our closest neighbor for billions of years. Also, the fact that our sea floors haven't been mapped as well. Yeah. Just so many unknowns out there that I don't want to rule anything out. I'm very optimistic in that way.
Another question from David. How did the Earth get its color?
Oh, interesting.
So maybe just talk about some like the different colors of the Earth and where those colors come from.
Sure. So our Earth is described as a blue marble, and that's because we have so much water covering our surface. But we also have these continents, right? So we have these kind of browns and greens covering the surface of our Earth. But we also have a lot of white as well. So if you see behind me, there's a lot of cloud cover. So if there was an alien spacecraft perhaps flying by our Earth, they would see some blues, whites, and greens.
All right. And of course, that's really kind of like really interesting point, because if we were on Mars, because quite often we look at Mars up in the nighttime sky and it appears red. So if we were standing on Mars, would we see Earth as being like a blue star?
It would be really far away, but I would hope that we'd be able to see that there's a little bit of blue there, a little bit of life there.
Yeah, there actually have been pictures that I have seen taken from the rovers on Mars looking back, but they're kind of hard to see. And of course, a camera eye is not the same as our eyes. So I think we probably would have to wait for a human to be standing on Mars, maybe looking at it for the first time to see if they would see our blue marble up there in the sky.
We do have the pale blue dot photo.
That's true. We do
Yeah.
that.
Yeah.
So just a few more minutes here, but we do want to invite everyone out there. We have a really special evening event coming up next week. Our Cosmic Nights, we've been doing them monthly. Next week's theme is Mars, because we've got a really fun new rover that's going up that's going to land onto the red planet. Is that right, Rachel?
Yeah, it's called Perseverance. I'm very excited to see what Perseverance will find.
So we're going to be sending that information out likely later on this afternoon or tomorrow. Make sure to look out for that virtual Cosmic Nights Mars. That is going to be on Wednesday, the 22nd. It's going to be an evening start, because we are going to be not only delving into Mars with Rachel, but also a special guest, Joelda Moranci from the University of Chicago. So we're going to have a lot of fun next evening. And then, as if that's not enough, on Thursday, our Q&A, we are inviting another Canadian astronaut to join with us. That is going to be Joshua Kutrick. So next Thursday here at 2 p.m., Rachel and I will be here, but we're going to be joined by Joshua. We're going to be talking all things humans in space. Joshua is down in Houston right now, where all the astronauts train. So make sure to come back around 2 p.m. to ask any of your questions for that. And And of course, for this week and every week, we have activities, lots of resources, blogs on our themes. You can go into the description and go to our website to check out some of those activities. And of course, if you enjoyed this content and you have any money to donate, we really appreciate it. Of course, the doors are still closed. We are doing some outdoor events. Check our website for some of those coming up next month and into September. For me, Michael, from my kitchen, Rachel, good to see you again. Everyone out there, I'll see you next week.